All right, so bell work again, super important for what we're about to do. Two different things, and both of them are basically the entire lesson. Okay, we are trying to convert 38.894 hours in terms of hours, minutes, and seconds. Okay, so we know we don't talk about time like that. It doesn't make any sense for us. It gets weird. Instead, we're going to convert it into 38 hours, blank amount of minutes, and blank amount of seconds. Anybody got an idea on how we could do that conversion? Aaron, what'd you do?
I took 0.894
0.894 times
times 60.
60. So let's see how that worked. So 0.894 times 60, because it's a part of an hour. It's not a full hour. It's only a 0.894 of an hour. She took that amount and multiplied it by 60, and that will tell her how many minutes there are. You get 53.64. So we don't want to write a decimal here. We're going to go 53 minutes. Then what'd you do from there, Aaron?
I took 0.64 times 60.
0.64. That 0.64 represents a part of a minute, not a full minute, but a portion of it. And we want to figure out how many is that in seconds. So she took 0.64 minutes and then multiplied that by 60 seconds to convert that. We get 38.4 seconds. And we're okay to leave it as 38.4 seconds. We know what 0.4 seconds is. We don't know what 0.894 hours is quite as well. Make sense on that conversion? So we did this, we got the 0.64, and then we took 0.64 times 60. We're doing the exact same thing today. Exact same thing, no different at all. Next one, and this one's even more important. You are creating a circular path with a radius of 1 mile. Okay, so here's what you got. You got our circle here. This radius is 1 mile. How far would you have to walk to travel around the entire path? So I'm going to start right here, and I'm going to walk around the entire path. Somebody got an idea for that one? What did you do, Megan? 2 pi r. What does 2 pi r do? The circumference, and circumference means? Yep, the perimeter of a circle. Her circumference formula is 2 pi r. And then what do we know? R is 1. So it's 2 pi times 1. Okay, cool. My answer is 2 pi miles. Okay, it's weird to leave it as 2 pi, but that's fine. It's 2 times 3.14, 6.28 miles. Both of them make the same deal. Okay, but 2 pi miles is totally fine. Understand what we just said. What we just said, that is, if you started right here and you were to walk all the way around the outside, it is 2 pi. What if I looked at you right now and I were to turn all the way around back to how I started looking at you? How many degrees did I turn? 360 degrees. That's different than me walking around the circle and back to the start. But it's kind of the same. They're both doing the same concept. One of them you're turning, one of them you're moving around the outside, but both of them describe a very similar concept. So 2 pi is the same as moving 360 degrees. That's super important. That's where we're headed in everything we're doing from here on out. Okay? This right here, this 2 pi is radians. Okay? We went 2 pi radians to walk around the outside of this circle. Okay? Imagine that I could draw better lines. But imagine that this right here is 1. Okay? That is 1. How many times do you think you could take this 1, that 1 radius, and wrap it around the outside? Like if you were to put it end to end, how many times do you think you would take that 1 and put it around the outside? Talk with your neighbor and discuss that as I pass out papers. How many of them do you think? All right, so not supposed to be a trick question, but for some of you it seemed like I was doing a trick question. It wasn't. Okay? The answer is 2 pi. Okay? Or 6.28. Okay? It's hard to draw. Yes, ma'am. Okay, I get it too. 1 second. Okay? Think about it. Now I'm just drawing general, but would you say that that blue line is the same length as that red line? Close enough. There's 1. There's 2. There's 3. And then I would get 0.14 more would get me across. Okay? That's what we're doing. When we say something is 2 pi radians, it means whatever your radius is, that's how many you would go around the outside. So if my radius was 10, it would take 10 pi amount of times to get around, because there's 1, 2, 3.14. That's what pi represents. It represents the distance around the circle in terms of your radius. So it's a little bit stranger, but that's where pi comes from. It's understanding that how far it is to get around. So today our main focus is angles. Okay, when you think about trigonometry, it is very much about angles and what's going on. All right, today we're going to do the most basic amount of angles, and a lot of stuff you should probably already know. Okay, just some vocabulary stuff. If we talk about an initial side, that's just where your angle starts, and then the terminal side is where it ends. Okay, so if I started here and went up that much, that's the initial, that's the terminal side. Estimate, how big do you think this angle is? I'd say it's 30. 45 would be a little bit higher, but 30 degrees. Okay, great. We went in a clockwise rotation. It gave me a positive angle. That's different than this other one. Okay, here's my initial side, and you can see with that red arrow that the terminal, or that the angle is going around the opposite way, and the terminal side's over there. We went counterclockwise the first time. Now we're going clockwise. Okay, we're going backwards. What angle do you think this is? If this one is 30 degrees, what do you think this one's going to be? 330 degrees, but it's not just going to be 330, it's going to be negative 330, because we went around the opposite direction. Okay, we have a negative angle here in the end, because we know 330 for one and 30 for the other, it should get us 360 overall, because we went all the way around. Okay, make sure you know quadrants 1, 2, 3, and 4. We've got to be able to know that. This is the first, the second, the third, and the fourth quadrant. That's something you should already know. We always put those in Roman numerals, so just be aware of that. All right, let's draw some angles. Draw each angle in standard position. If we can, we're going to state which quadrant it lies in. Not always are we going to state a quadrant, but we'll see what we can do. So we're going to draw a little baby graph. We're going to draw 120 degrees in standard position. Standard position just means my initial side is going to be right here, right on the x-axis going out. If I'm going to 120 degrees, which quadrant am I going to end up in? The second one. Am I going to be in the top half of the second quadrant or the bottom half? Top. That's a dumb question, but I asked it anyway, so deal with it. Okay, that right there is 120 degrees. Okay, I do want you to draw an arrow that represents how you opened, because if you don't draw that, it would be significantly different. So I drew my arrow that way. I'm going to say that's 120 degrees. And I am in the second quadrant. Just drawing an angle. Okay, let's try and do number 2, negative 90 degrees. So negative 90 degrees, I'm starting right here. If I'm drawing negative 90 degrees, which quadrant am I going to end up in? Point, where are you going to end up? Point, where are you going to end up? If I'm doing negative 90, I'm going to end up at the bottom. Okay? I'm not ending up in any quadrant. I'm going right there. That is a 90-degree angle. Because it's negative, it means I'm going down. So this was my starting side. That was my ending side. I'm not going to list a quadrant because I'm not in a quadrant. Okay? I'm on an axis here. Does that make sense on B? Try C and D with your neighbor. All right, let's do it. There's my base angle. Show me with your fingers, which quadrant am I ending up in to get to 225 degrees? Show me with your fingers, which quadrant is 225 degrees in? 225 should be in the third quadrant. Here's 90 degrees. If I went to that point, if I went straight up, that would be 90. If I went straight over, that's 180. If I went down here, that's 270. That's too much. 225 would fall right in between 180 and 270, so it'd be right there in the middle. We're going to, again, draw our angle just so we can see it. It's that thing right there. I am in the third quadrant. Now we're going to draw 900 degrees, so we're starting right here. Max, what'd you do here to draw 900 degrees? What? Whoa. You went around? All the way around? Good. 900 is more than a single rotation because one rotation would be 360. So we started off here and he is subtracting out 360. Okay. If he went 360 degrees, that's all the way around. That gets him 540. And so Max said he already knew that if it's 540, he's going around again. It's 2 full rotations. He just subtracted it out again. That left him with 180 degrees. He just subtracted 360. Subtracted 360. Then what? And he were to keep going until that spot right there. Okay. So if you're up on your skateboarding, a 900 is going around 2 times and then a half more. 2.5 turns is a 900. It is exciting. That's our angle. Obviously, we're not in any quadrants, so we aren't going to put anything. Just show me real quick. Do one more. Let's graph negative. Let's do negative 510. Graph negative 510. Show me with your fingers. Which quadrant are we going to end up in if we're doing negative 510? Negative 510. We're getting a lot of 3s. Aaron, talk me through. How'd you do negative 510? We went clockwise around once. So it's like you could add 360 to it because you know it's bigger than that. And you're left with negative 150. So then what? Wonderful. So this is 90 degrees. She wants to get to 150. So not 180. 180 would be all the way over, but she's just said 30 degrees away. So she's going to go to right about there. There's my angle. It is, that's weird that I randomly broke it there, but yeah, you get the idea. It is negative 510 degrees, and I'm in quadrant 3. Makes sense on how we draw angles? Great. Let's talk about angles in degree, minute, and second notation. Okay. The place you'll see this is in longitude and latitude. Okay. When you do longitude and latitude, you will see degrees, minutes, and seconds. Okay. Because if you take the whole world and you split it into 360 degrees, you can miss a lot if you just go 1 degree. Okay. So by separating that, it makes it a more precise measurement. I'm not particularly sure why they go minutes and seconds and not just decimals, but they do. And we're going to be able to convert back and forth. The good news is exactly like what we already know what to do. Okay. 1 minute, when we talk about degrees, is 1/60th of a degree, just like 1/60th of an hour, of an hour. Okay. 1 second, it's 1 with 2 apostrophes at the end. It's defined as 1/60th of a minute, or 1/360th of a degree. So if we had 30 degrees, 40 minutes, and 10 seconds, we would write it like that. 30 degrees, 40 with an apostrophe, and 10 with a double apostrophe. Everybody good there? Convert this thing. You've got 50 degrees, 6 minutes, and 21 seconds. Convert it into degrees as a decimal. You know how to do that. Okay? Think of it like hours, minutes, seconds, and make that conversion. Do that with your neighbor, and you can do the other one as well. Convert 21.256 degrees to degrees, minutes, and seconds. Use your brain. Figure it out. We'll talk about it here in a second. We are converting 50 degrees, 6 minutes, and 21 seconds to degrees as a decimal. Somebody want to talk me through what you did? What do you got for me?
So I started with just 50 and the decimal point.
So 50 dot, because we know that that is a full degree. So 50 degrees. And then what?
And I did 6 times 1/60th for the minute to get 0.1.
Let's hang on. So 50 dot. So you did 6 times 0.60. Right? 1/60th. My fault. I was doing weird stuff. 1/60th. Because we are taking that 6 minutes and we want to convert it back. So we're going to divide by 160. Great. And what else did you do?
And then I did 21 times 1 over
3,600. She's picking 3,600 because we are taking that decimal and we are converting seconds, which is 3,600 in a hour, or in a degree here, or 60 times 60 down there. Okay, that little conversion is all I need to do. So in my calculator, you can do 50 plus 6 divided by 60, and then plus, what was it, 21? 21 divided by 3,600. Hit enter, boom, 50.106 is going to be my answer written in the decimal. Degrees. The other one we already did. We are converting 21.256 degrees into degrees, minutes, and seconds. So we're taking 21 degrees, blank amount of minutes, and blank amount of seconds. Jack, what'd you do? So we took this extra amount of an hour and multiplied it by 60 to tell him how many minutes that was. So he then got, can't find my calculator, 0.256 times 60. It tells you that it's 15.36 minutes. So 15. Then what'd you do? Took the 0.36 and then multiplied that by 60. Okay, so in his calculator, he took the leftover minutes, the 0.36, and multiplied that by 60 seconds, and got 21.6 seconds. That's not hard. Be able to show me your work. Okay, break out your graphing calculator. Let's look at it real quick on there as well. So in your graphing calculator, you can do all of these things. Okay, 50 degrees, 6 minutes, and 21 seconds. So I'm going to go 50. Then I'm going to go second angle. Okay, angle is right here with the apps button. So second and angle, the apps button. And there's a little degree button. So I'm going to hit that, 50 degrees. 6 minutes. So again, I'm going to go second angle. I'm going to go down to the little minute guy, the little apostrophe. I'm going to hit enter. And then I want 21 seconds. To get seconds, to get 2 apostrophes, it's not in the angle menu. I don't know why they did this to us, but they hate us. Okay, but we're going to go alpha, and it's down here with the plus sign. See where it is right here? It's right there. You got the little apostrophe. Once you've typed that in degrees, minutes, and seconds, all you got to do is hit enter. And it gets me 50.106, just like we wanted. Makes sense on that one. We can go the other way as well. So look at the other one. The second problem was 21.256. Okay, degrees. We want to convert that into degrees, minutes, and seconds. To do that, I typed in my decimal. Then I'm going to go second angle, sorry. I'm going to the angle menu again. Number 4 is converting to degrees, minutes, and seconds. So I'm going to go down to number 4, degrees, minutes, and seconds. All I got to do is hit enter. Boom, there's my answer, 21 degrees, 15 minutes, and 21.6 seconds. Makes sense how to convert. I'm perfectly happy with you being able to check your work that way, but be able to show it to me as well. Be able to show that, hey, I divided by 60 and I divided this thing by 3,600. Questions with that conversion? That is not the most important part of today. Flip that over to the backside. This is the most important thing of the day. We talked about this in bell work. We said that if we go all the way around a circle, it is 360 degrees. How far is it to walk all the way around the outside if your radius is 1? It is 2 pi. So we know that 2 pi radians, and that's what it is. It's how many radians you need. Again, that thing that I tried to illustrate earlier. You get 1, and then you get 2, and then 3.14, and then 1, and then 2, and then 3.14. 6.28 radians around. 2 pi radians is the same thing as 180, as 360 degrees. So how many, if I just have 1 pi radians, how many degrees is that? 180, because this is 180 degrees. It's also just a single pi. 2 pi if I go all the way around. 1 pi if I go half the way around. Everybody go with that? All right. So now what we're going to do is we're going to convert degrees to radians. If I have 180 degrees, how many radians is that? Pi. Done. We just said that. Pi 180. All right, but let's look at converting. 150 degrees. If I want to convert degrees to radians, we are going to multiply by a fraction. And the fraction should be very simple. The conversion that we know is that pi radians is the same thing as 180 degrees. So what we want to do is if I want to put this into radians, I want to get rid of the degrees. So the 180 degrees goes on bottom because I need the degrees to cancel out. If I put 180 degrees on bottom, what is the same that's going to go on top? Pi. That's just like multiplying by 1 because the top and bottom are the same, but it allows me to convert just like you do in your science classes. Okay? So from here, these are going to cancel. Don't get out your calculator for this one. You got to be able to reduce this without a calculator. 150 pi over 180. Then we can reduce. What can I divide both things by? I can divide them both by 10. I always do that first. And I get 15 pi over 18. Then what could I divide that by? 3. If I divide both of them by 3, I get 5 pi over 6. You could just divide by 30 at first if that's in your skill set. Great. But I canceled out the zeros, and then I simplify. Questions there? So again, when we multiply here, we're putting pi on top, and I want to get rid of degrees. Do the last 2. Do 3 and 4 with your neighbor. Okay, if you need a calculator on 3, I'm okay with that. But on 4, you don't need one. Okay, take a second and do that real quick. Go. Here we go. We're converting, so we're multiplying by pi, dividing by 180. So it's 225 pi over 180. All I got to do is simplify that. What does that simplify into, Kate? What do you simplify that to get?
5 over 4.
Yep. Good. 5 pi over 4. That is converted to radians. And if we did 60 degrees here, Matthew, what'd you multiply by? Pi over 180. Pi goes on top. 180 degrees goes on bottom. That way the degrees can cancel. What do you simplify that to get you? Pi over 3. Boom. Converted. Great. Okay, let's look at the next one. Now we're just going to go the opposite way. Now we're converting from radians to degrees. When we're converting to degrees, you might need a calculator. Okay, we're going from radians to degrees. So I'm going to multiply this thing. I am in radians. I've got a pi in my answer. I want to convert this thing if I want to get rid of pi. Degrees doesn't have pi in it. So that's going to tell me, hey, I need to put pi on bottom, and I need to include degrees in my answer. So I'm putting 180 degrees on top and pi on bottom. The reason I'm doing that is because I don't want pi, and I want my units to be degrees. Then I just do it. In my calculator, I'm taking 7 times 180 and dividing it by 8. So 7 times 180 and dividing that thing by 8. I hit enter. I get 157.5. 157.5 degrees. That is my answer. That is converting from radians to degrees. Makes sense on 6. Do 7, 8, 9 with your neighbor. Go. 2 degrees. Ella, what'd you multiply 5 pi over 6 by? 180 over pi. And when you type that into your calculator, what'd you get? 150 degrees. Great. Next one, Sam. McCain, what'd you multiply by? Still 180 over pi, because I'm still getting rid of pi, and I still want it to be in degrees. What answer did you get? 67.5 degrees. And then, Kendall, what'd you do on 9? 180 over pi. We want to get rid of the pi's and get degree in our answer. What'd you get for your final answer? 480 degrees. Talk with your neighbor. Explain to each other why it makes sense that your answer is greater than 360 degrees. Talk to each other. Why does it make sense that it's greater than 360? Kara, why does it make sense that my answer that I got here was greater than 360 degrees? Yeah, because 2 pi is all the way around. So if she were to reduce 8 pi over 3 and put that as a mixed number, she would get 2 and 2/3. Okay, and so 2 pi is 360 degrees, and so she would need to go 2/3 more around the top to get her answer, which makes sense that it's bigger than that. All right, down below, we are finding the arc length of an arc using radians. And I'm going to talk through a big fancy formula. And then you probably will never remember that formula again, and that's okay. All right, instead, use your brain and be able to figure this stuff out. Okay, if I want to find arc length, the formula that we use is S is equal to R times theta. S in this problem stands for the arc length. R stands for radians. And theta, I'm sorry, just playing, radius. And theta stands for your angle in radians. Okay, arc length is S, R is my radius, and theta is my angle in radians. Okay, number 1 says find the length of the arc of a circle of a radius of 2 meters subtended by a central angle of 0.25 radians. That seems really fancy. Let me show you what that is describing. You've got a circle. Okay, the radius is 2 meters. You want to find the arc length of the circle that is subtended by a central angle of 0.25 radians. What that means is you have a radius, or I'm sorry, an angle right there of 0.25 radians. Your job is to find the arc length. You want to know this part right here. That is the mystery number. How long is that little baby line right there? That's what we're trying to figure out. To do that, it is this simple formula of S is equal to R times theta. What do I know here? The radius is 2. What is my angle going to be? 0.25. 2 times 0.25 is 0.5 meters. It's easy. We just plugged it in and solved. Okay, don't let it be harder than that. Now let's look at number 2. Okay, let's act like we didn't think about that at all. Okay, that formula is great. The problem with the formula in this one is I'm not in radians. Okay, I'm in degrees. But really, it makes more sense to us if we are in this one. I want to know only this little portion of the full circle. If I wanted to find the full circle, what would I use? Circumference equals 2 pi r. Okay, what would the circumference of this circle be? 16 pi, because the radius is 8. That's not the answer to this question. That is the full circle. Figure out with your neighbor here, just use your brain, figure out what that arc length is going to be. Go. You can keep it in terms of pi. You don't need to multiply the pi and see what you can do. Annika, what'd you do here? Good. So 60 is 1/6 of the entire circle. And so she's doing good math there. Or she could just say, hey, she's got 60 degrees out of the total 360. And if she reduced that, you would absolutely get 1/6. Good. And so what'd you do? Okay, so she said she did it better here because she said she took 16 pi, and since it's like dividing by 6, she divided by 6 and then reduced from there, divided both things by 2. She gets 8 pi over 3. That is my final answer. We could go decimal, that's fine, but that's going to be my answer. You didn't need a formula for that. You could use your brain. Okay, let's act like we did use the formula. S equals R times theta. My R is going to be 8. What's the problem with theta here? I'm in degrees, so I would have to convert it first. I would have to take 60 degrees, and I would have to multiply by, what would I have to multiply by? Pi over 180, because I want to convert it. Okay? If I did that, I would get this. I could divide both of them by 10. I get 42 over 18. That's super ugly. Let's make that 9 and make that 4. And then I could divide that by 2 and divide, or by 3, and then divide that by 3. Oh, guess what? I get 8 pi over 3. I did some weird conversions in there, but that's the same thing. You could use the formula or you could use your brain. Use your brain. It's helpful. Questions there? Next one. Find the area of a sector. Okay? This is absolutely just a SAT question. Okay? Find the area of the shaded region. You got a whole circle. You're finding the area of just the shaded region. Find the area of a sector, which just means that kind of shape, of a circle with a radius of 2 feet formed by an angle of 30 degrees. I could give you a formula, but if I gave you a formula, 2 minutes later you would forget it. Use your brain, figure it out. Go. We're trying to find area here, right? Okay, you're good. Area. So we're finding area here. Kendall, what'd you do?
I found the area for the whole circle.
Yeah, what's our formula for that?
Pi squared.
Pi r squared. And so the area for the full circle would be 4 pi, because it'd be 2 pi squared. So we get 4 pi. Great. What do you need to do with that?
And then I multiply that by 30 degrees over 360.
Yeah, because we only want a portion of that circle. I don't want the whole thing. I just want 30 over 360. Okay? Or in other words, I could divide that and I get 12 pi over 36, otherwise known as pi over 3. It's way easier to leave it in terms of pi than getting some random decimal. If I want to get a decimal, I can do that, but here I'm good as well. Questions on something we did today? Next thing I need